Hi all, my name is Vinesh, and for my final project I have chosen food delivery using drones. It is a vehicle routing problem. So let's get deep into it. What are the constraints and details that I've added for the vehicle routing thing using drones? So we're going to see about the introduction, problem statement, value proposition methodology, and what details that I've included for formulating a vehicle route for the drones. So let's get deep into the drones. We all thought that drones were introduced in the latest 21st century, but its usage dates back to 1800, where it was used primarily in military service for bomb detection, target practice, airstrikes, and training. Drones are currently used by companies for food delivery, which changes the traditional way of delivering through cars and bikes. Drones are operated by satellites, GPS, sonar sensors, and can also navigate through cameras if operated manually. The first drone delivery happened in New Zealand with a trial, and the food delivered was a pizza. Drone delivery is a cost effective way to deliver foods which has an expanding wide range of customers, promotes safety and eco-friendly options for the environment. Now we are going to see about the problem statement. Manual food delivery is time consuming due to traffic jams and road accidents, and also due to manual food delivery, road accidents and traffic jams seems to increase in the future. Not only that, the food safety and the authenticity of the food is also affected if the food is not delivered within a proper time constraint. There seems to be increased road traffic and the food delivered to the wrong address happen often. So the solution I am proposing will be to use drones for delivering foods, which will improve the customer satisfaction, reduce delivery times, improves food safety, and the traffic accidents, most importantly, can be prevented. The food delivered to the right address can also be taken place with effective routing, and it promotes faster and safer way of delivering food to the customers. For finding the effective customer location, and the tools that I'll be using for routing the drone would be OpenSolver in Excel, and it has been optimized using Groby. And I've also used Python programming for finding the distance metrics. Constraints like distance, capacity, assignment constraints, subtotal elimination, and victim tracking constraints are also obtained. And for the depot location, I've taken Domino's, which is located in Queenpool. And for the data, I've taken like 25 customers with within a range of 1 to 15 kilometers. So these are the customers' location that I've taken, and the last is the depot location. It represents the lat and the long. And this is the distance matrix that I've obtained using the Python code. So for solving this, I've taken two drones. The drone one, which is a quadrat drone, and the drone 2, which is made by a brand name called Hanu. The main objective function would be to minimize the distance. For that, I've taken 25 customers and 5 drones. I've used capacity constraint so that it carries defined capacity of the drones. I've also used assignment constraint so that the drone has one enter and one exit for every node except the depot. And also I've used subtotal elimination to eliminate the longest path and finding the shortest path. Vehicle tracking constraint is also used so that the vehicle covers all the location of the customers. And I've also used the distance constraint which every drone has a battery and it has a specified range of distance, so that while routing the drone travels within the specified distance depending upon the battery's range. So I've used three cases. For case 1 and 2, I'm gonna use the same drone, and for case 3, I'm gonna use a different drone. So the capacities of the drones for the case 1 and 2 are 30 kg, and for case 3 it's 22 kg. The maximum distance for case 1 that the drone can travel is 25 kilometers, for case 2 it's 30 kilometers, and for case 3 it's 18 kilometers. And the demand of the food, I've taken it in kg. For drone 1, it has a demand of 115 kgs. I've kept the kgs as constant for case 1 and 2. And for 3, I've taken low, that is 96 kgs. So the total capacity for cases 1 and 2, I've used the same drone, so it's 150 kgs. And for case 3, it's 110 kgs. The number of vehicles I've used for all the cases are 5. So after putting all the constraints and running the model through Excel, these are the results I've got. So in case 1, the maximum payload that the drone can carry was 30 kgs, and it has almost obtained like greater than 25 kgs. And 4 drones were used, 1 was idle. The time taken for drone 2 was 56 minutes, and all the respective drones are given. These are the results for case 2. Also for the case 2, I've just increased the distance travel of the drone by changing it with a different battery so that it also uses 4 drones and 1 is kept idle. And the maximum payload that it can carry was 30 kgs, and it has almost used the 30 kgs. And these are the results for case 3. I've taken case 3 as low demand, so I've used a different demand and I've used a different drone with a different payload. The maximum capacity that the drone can carry is 22 kgs, and it almost does a pretty good job in that. So here no drone is being placed idle, which means every drone is placed in operation. This is the route of the drones obtained for the case 1 and for the case 2 and for the case 3. After running through the models, I have obtained the optimum delivery route for the drone 1, which was 63 kilometers, which was same for both the cases. And for drone 2, the optimal distance was 69 kilometers, which was used in a lower demand of food orders. So drone 1 will be used in situations where there is a higher demand of foods orders, and drone 2 in situations where there is a medium or low demand of orders. Using drones for delivery reduces road traffic, which aids in safer and faster delivery of foods to the customers, maintaining food safety and authenticity. Drones are travel from point to point, which naturally reduces the distance and traveling through road, and using effective routing options we can make it more better for the future. The future scope would be to add climatic condition as a constraint and deal with return food, which would be a greater job if done successfully. Thank you.